Python. It's the programming language that's pretty much everywhere you look. It's behind Instagram, Spotify, even NASA's data analysis. It is consistently, year after year, one of the most loved and most used languages on the entire planet. So we've got to dive into this, because if something is that popular, there has to be a story there. And as you're about to see, there's a really fascinating paradox right at the heart of it all. And look, this isn't just hype. The experts all agree. Python has become a true titan in the coding world. It gets praised for being so clean, so intuitive, and it's backed by this massive, thriving global community. It's the language a ton of people learn first, and it's also the language that many experts turn to for their most complex projects.
And when we say a massive community, we are not kidding. We're talking about over 8 million Python developers across the globe. Just think about that. That's a huge pool of talent, of support, and of innovation, all building on the same platform. That community, right there, is a massive part of its strength. So that brings us right to the main question of this whole explainer. I mean, nothing is perfect, right? If Python is this easy to use, this versatile, and this widely adopted, where's the catch? What's the fundamental trade-off that every single developer has to think about?
Okay, so to really get the paradox, we first have to understand the appeal. Let's break down the superpowers that make Python the absolute go-to language for millions of developers and, frankly, some of the world's biggest companies.
Python's #1 superpower, without a doubt, is its simplicity. The entire philosophy behind the language is that code should be easy to read and easy to write. It completely avoids a lot of the confusing symbols and syntax that can make other languages feel so intimidating, especially if you're a beginner. And this comparison right here shows you that philosophy in action. Just look, on the left, you've got Java, a more, let's say, verbose language, where you need a bunch of extra setup just to get the job done. But on the right, that's the Python way. It's fewer, cleaner lines to get the exact same result. It's all about getting straight to the point with a lot less ceremony. And the payoff for that simplicity is absolutely huge. You see, less code means faster development. It means fewer places for bugs to hide and way less time spent debugging. And that efficiency, it's a massive competitive advantage. It lets teams build and test out ideas so much faster. So Python's second superpower is its incredible versatility. This is not some niche language that's built for just one thing. Oh no, you can use it for building websites, for data science, for automating boring tasks. You can even make simple games with it. It is a true jack of all trades. Now you put those two things together, simplicity and versatility, and you create this huge real-world advantage. When you have a language like that, you have the perfect tool for startups. I mean, companies like Instagram, Dropbox, and Spotify, they all used Python in their early days to quickly build and launch, proving their ideas without getting totally bogged down in complicated code.
Okay, so Python is simple, it's versatile, and it's fast to develop with. I mean, it sounds perfect. But now we come to the other side of the coin, the catch we talked about earlier. Python has one widely known critical weakness: speed. This quote from a developer on Reddit just cuts right to the chase. In the world of high-frequency trading, where literally every nanosecond counts, Python is often just dismissed immediately. And why? Because compared to languages like C++ or Java, Python's raw execution speed is just, well, it's significantly slower. The main technical reason for this is something called the Global Interpreter Lock, or the GIL. Now, without getting too deep into the technical weeds, just think of it like this. Even if your computer has multiple cores designed to do a bunch of things at once, the GIL basically forces Python to only use one of them at a time for certain tasks. It just creates a bottleneck and stops true parallel computing from happening. So in the real world, this technical limitation leads to some very practical problems. It's slower than compiled languages, it can eat up a lot of memory, it's really not the best choice for building native mobile apps, and, get this, because it checks for errors as the program is running, some bugs might only pop up after you've already shipped your code. Yikes! And right here, this is the heart of the paradox. If Python is slow, if it's memory hungry and limited by this GIL thing, then how on earth did it become the undisputed king of some of the most computationally demanding fields out there, like artificial intelligence and big data? It doesn't seem to make sense, does it? Well, the answer doesn't actually lie in the language's raw speed. The answer, and Python's true secret weapon, is its ecosystem. This is what turns its biggest weakness into, really, a manageable trade-off.
And this is so key. You just can't evaluate Python in a vacuum. Its real power comes from the decades of tools, libraries, and frameworks that the community has built all around it. And, crucially, these are the tools that solve the performance problem.
Right. This is where the magic happens. Many of Python's most famous libraries, like NumPy and TensorFlow, actually have their high-performance guts written in faster languages like C++. So Python just acts as the simple, easy-to-use control panel for that powerful engine. You get the best of both worlds, easy development and lightning-fast execution right where it counts.
A perfect example of this ecosystem in action is the Jupyter Notebook. It's this incredible interactive tool that lets data scientists write code, see their charts and graphs, and add notes all in one place. It has totally revolutionized data analysis and machine learning, and has become a cornerstone of the Python world.
And on top of all that, this ecosystem has some serious backing. We're talking tech giants like Google, who developed TensorFlow, and Meta, who developed PyTorch. They pour millions of dollars into these Python libraries. That corporate support means they're reliable, they're well-maintained, and they're constantly getting better. So, where does that leave us? What have we learned? Let's bring this all together and solve the Python paradox once and for all. What's the final verdict here?
Well, the paradox basically disappears the moment you stop thinking about which language is the best and you start thinking about trade-offs. You see, Python isn't a magic bullet, but it makes a very specific and a very powerful bargain.
This table really sums it all up, doesn't it? You use Python when getting something built fast is your top priority, when you need access to that incredible AI and data science toolkit, or when you're just building a prototype. And you look for something else when every nanosecond of raw speed matters, when you're building a native mobile app, or when memory usage is your absolute biggest concern.
And that really is the ultimate takeaway. Python's core trade-off is this. You trade developer time for machine time. And for a huge number of modern applications, especially in a world that's driven by data and rapid innovation, that turns out to be an incredibly smart bet. So the final question is, for whatever you want to build, which side of that trade makes the most sense?